Okay, so welcome to our geometry and trigonometry class. So this is quarter 3, week 1, and we are into the topic trigonometry, angles, and angle measurements. So these are some of the basics of trigonometry. So the first thing that we're going to do is to discuss what is trigonometry. So trigonometry comes from two words. All right. So the first one is we have trigonon, meaning it's a triangle, and metron, meaning measure. So the definition of trigonometry is it is a branch of mathematics that studies relationships between side lengths and angles of triangles. So trigonometry simply means measures of triangles. Right. So the next important thing that we need to discuss is the definition of an angle. So what is an angle? So an angle is made up of two rays with a common initial point. So these are the two rays. So we have the first one, we have the initial side. So the initial side is also the stationary ray. So when we say that it is the stationary ray, it does not move. So it lies along the x-axis. Now, we also have what we call as the terminal side. So the terminal side is the rotating ray. So meaning to say, it is the side of the angle that is moving. So the terminal side can move either counterclockwise or clockwise direction. So in standard position, we say that an angle is in standard position if the initial side is always on the x-axis. So we say that this initial side lies always along the x-axis. So that is an angle in standard position. So let's now differentiate between what a positive angle is and a negative angle. So we say that if an angle is positive, so say for example, this first angle, okay? So this one is positive. Now, how do we know if the angle is a positive one or it is a positive angle? Now, let's look at the definition. If the terminal arm, okay, or the terminal side moves counterclockwise. So, the angle is a positive angle. So, meaning to say, if it moves counterclockwise, so this is the initial side, okay, so I have here the initial side, and then this one is the terminal side. Now, if the terminal side moves counterclockwise from the initial side, so that is a positive angle. Okay? So, what is an example of that? So, if we draw an angle, so we know that an angle is positive. Say, for example, this one. Okay, so if this is 45 degrees angle, so it begins from the initial side. Okay, so the terminal side moves going to there. You add again another one. So this one is 60 degrees. And then again, you move. So this one is 90 degrees. And then you move again. So this is 180 degrees. And then you rotate again. Okay, counterclockwise. So this is 270 degrees. And then you again move. So this one is 360 degrees. So if it moves, the terminal side moves counterclockwise, we know that all of the angles will become positive. Now, how do we know if the angle is negative? So, if the terminal side moves clockwise, then the angle is negative. So in this case, the terminal side moves from the initial side, okay, clockwise. All right, so like that. So this becomes negative. So let's simply estimate. So, example, because it moves clockwise, so this becomes, say for example, if we estimate this is negative 60 degrees. Okay? Now, if the terminal side moves again clockwise, going to this, to the y-axis, so this one becomes negative 90 degrees. And then if it moves again clockwise, going to there, so that becomes negative 180 degrees. So again, if it moves clockwise, going to there in the y-axis, so this becomes negative 270 degrees. So again, move going to the x-axis, so this becomes negative 360 degrees. So that is the difference between a positive angle and a negative angle. Alright, so we have mentioned a while ago already angles in standard position. So what are angles in standard position? We can say that an angle is in standard position if its vertex is located at the origin. So in this case, if you look at this, so the vertex of this angle is located at the origin and one ray is on the positive x-axis. Okay, so one ray is on the positive x-axis. So we know that this one, this side, so this is the initial side, one ray is on the positive x-axis. So we know that this is the x-axis, positive, and then this one is negative. So this is already an angle in standard position. Okay, so next, the ray on the x-axis is called the initial side and the other ray is called the terminal side. So we discussed that already. Now, if the terminal side of an angle lies on the axis or on the axis such as 0 degrees, 90 degrees, 180, 270 degrees, and 360, it is called a quadrantal angle. Now, how do we illustrate quadrantal angles? So, if we have a Cartesian plane, okay, and then we have the initial. So, say for example, I am going to draw here the initial side or the initial ray of the angle. And then, let's move, okay? So, this one is the terminal side, okay? So that is the terminal side. Now, we already formed an angle. So this one is a 90-degree angle. So because it is located, okay, along the axis, okay, both in the x and the y axis. So we say that this one is a quadrantal angle. Okay? So next, another, if we move this terminal side again, going to that side, so this is the negative x-axis. Okay? So we have that one, 180 degrees. Okay? So it is also a quadrantal angle. Now, if we again move, okay, going to this axis, okay, so that's y. Alright? So again, that's 270 quadrantal angle. And then, move again. All right. So similar to 180, that is 360, it is still a quadrantal angle. All right. So again, how do we define a quadrantal angle? So a quadrantal angle happens if the terminal side of an angle lies on the axis. So we can say it can lie on the 0 degrees, then 90 degrees, 180 degrees, 270, or 360 degrees. All right, so we also have the reference angles. So what is a reference angle? So by definition here, so the reference angle is an acute angle. So it is the smallest angle. Now, take note that reference angles are always the smallest angles. So these are formed by the terminal side, okay, of the given angle and the x-axis. Now, reference angles may appear in all four quadrants. So from quadrant 1 to quadrant 4, you can find reference angles. Now, let's look at this reference angle for quadrant 1. So if this is our angle, Okay, so 60 degrees. So we say that a reference angle is always the smallest angle formed by the terminal side. So that is the terminal side of the given angle and the x-axis. So this is the x-axis. Alright, so in this case, so it is 60 degrees. Okay, because it is already the smallest angle. So the reference angle here is 60 degrees. Now, if we look at here in quadrant 2, okay, so the angle here is 120 degrees. But, so we say that the reference angle is always the smallest angle. Now, it is always positive and less than 90 degrees. So we cannot get here 120 degrees. So what are we going to do? You look for the x-axis. So this is the x-axis, and you look for the terminal side. So this one is the terminal side. And then from the uh, initial side or x-axis, so this is the x-axis. And then you go to the terminal side. Okay, so the measurement of this is 60 degrees. So that is the reference angle. Now, how about in quadrant 3? So in quadrant 3, you have 240 degrees. Okay, this red arrow, 240 degrees. Now, again, how do we find the reference angle? It should be the smallest angle coming from the x-axis to the terminal side. So this is the x-axis, then going to the terminal side. So this is 60 degrees. Okay? Now, how about in quadrant number 4? So we have 315 degrees. So again, how do we find the reference angle? It is the smallest angle coming from the x-axis to the terminal side. So this is the x-axis, and then we go to the terminal side. So for example, so this is 45 degrees. So going back to our reference angles, how are we going to solve for the reference angle? So in the first example here in quadrant 1, there is no problem because it's already given that the reference angle is 60 degrees. Now, in the second quadrant here, okay, how are we going to solve for the reference angle? So if we have 120 degrees already here, 120 degrees, and we know that the reference angle must come from the x-axis going to the terminal side. Now, the total of this is 120 now plus a number, and it will become 180 degrees. So, in this case, 180 degrees minus 120 degrees will be equal to 60 degrees. So that is the reference angle. Okay? So, in the third quadrant, so we know that we have 240 degrees already. Okay? So, 240 degrees. But the reference angle should always come from the x-axis going to the terminal side. Now, what happens here is that you have 240 degrees already. So 240 degrees. And we are going to subtract 180 degrees to get the reference angle. Now, why do we need to subtract 180? Because here, this is already 180 degrees, and the entire angle with the red arrow, so this one, the entire angle is 240. So 240 minus 180 degrees will be 60 degrees. So that is our reference angle in quadrant 3. Now, for quadrant 4, so we have 315 degrees. Okay, so we have 315 degrees. And we know that if we have a complete, okay, movement, we have a complete movement. So from our initial side again, going to the x-axis, one whole entire counterclockwise direction. So that would be 360 degrees. So to get the reference angle, so we have 360 degrees, subtract it to 315 degrees, so we have 45 degrees. So that is how we find the reference angles. Alright, so we also have what we call as the coterminal angles. So what are coterminal angles? So we say that when angles, okay, have the same initial side and terminal side, so they are called coterminal angles. So these are angles having the same initial side and terminal side. So let's look at this example. Okay, so this angle here, okay, so one angle can be represented with this arrow. So this one is one angle. Okay, another one is this one. Okay, so that is another angle, but still the same initial side and terminal side. So if I'm going also to rotate, okay, clockwise. All right, so the same. So it's still coterminal. Now, let's look at this example. Find the coterminal angles to 30 degrees. So, if we're going to draw 30 degrees, similar to this example, okay, but I am going to draw a separate one, okay? So, 30 degrees most probably is here, okay? So, let's just estimate. So, that is our 30-degree angle. Okay? So, find a coterminal angle to 30 degrees. So, it can be a positive angle or it can be a negative angle. Now, if it's positive angle, so beginning from your initial side, okay, going to the terminal and then going counterclockwise. Okay, so that's it. Okay, so we say that the beginning angle is 30 degrees. Okay, so we move again going to 360 degrees. So that's plus 360 degrees. So we have 390 degrees. Okay, so that's one for positive. Now, if you like another coterminal angle, so this is only one entire, so complete 360 degrees. Okay? So if you wanted 2, you can do so. So you again add 360 and so on and so forth. So if you want 3, 4, 5, okay, that's okay. But if it is 1, so 360 times 1. So that is 360. If you want 2, so you multiply 360 by 2. If you want 3, you multiply by 3. So that will still produce the coterminal angle that is positive. Now, for negative coterminal angle, so we have already our 30 degrees, okay? But we are going to move, okay, clockwise. So if it is clockwise, so one entire, okay, so 360 degrees. So from our initial side, we move going to there. All right. So that's it. So meaning to say, we have 30 degrees, so we subtract it, okay? We subtract 360 degrees. So we have this one. So 30 degrees, okay, minus 360 degrees. So we have negative 330 degrees. So that's it. So that's how you find coterminal angles to 30 degrees. So one is positive and the other is negative. Okay? So another, find the coterminal angles to 110 degrees. So this is the illustration. Now it's very easy. If you're going to consider positive, so we can say that we have 110 degrees and then we add 360 degrees. So our answer will be 110 degrees plus 360 degrees. So that is 470 degrees. Okay? So, next. So, if we're going to consider negative angle, so that would be 110 degrees less or minus 360 degrees. So, what will be our answer? So, 110 degrees minus 360 degrees, that would be negative 250 degrees. Again, if you want to have it, okay, uh, one complete 360. Okay, movement. Then you can multiply it by 1, then by 2, and so on and so forth. So similarly, if you have negative, okay, so you can just move, okay, so that is clockwise or times 2. Okay, so that's it. So that's how you find coterminal angles. All right, so let's have some more examples. So we are required here to find a positive and negative coterminal angle to 150 degrees. Okay, so as we have learned a while ago, so get one coterminal angle positive to 150. So what are we going to do? We will just add 360 degrees. So 150 degrees plus 360 degrees, so that is equal to 510 degrees. So that is for our positive. Okay? So meaning to say, we add 360 degrees. Okay? To our 150 degrees. Okay, so that's it. Next, for our negative, we have 150 degrees minus 360 degrees. So our answer is 150 minus 360, that is equal to negative 210 degrees. Alright, so these are our two answers. One is positive and one is negative. Now, how about negative 240 degrees? So, one positive. So, negative 240 degrees plus 360 degrees. So, our answer would be, so negative 240 plus 360 degrees is 120 degrees. All right, so that is for our positive. Now, for our negative, so negative 240 degrees minus 360 degrees. Okay, so negative 240 degrees minus 360 degrees is negative 600 degrees. Okay, so that is one positive and then one negative. Now, for the last example, so we have 570, okay, 570 degrees. So, we have, you can add uh, plus 360 degrees or you can also subtract, okay? So, if we add here, so add 360 degrees, okay, so that will be 570 plus 360 degrees, so that is 930 degrees. Okay, so if we are looking for the lowest positive, so that will be 570 degrees minus 360 degrees. So 570 minus 360, so that is 210 degrees. So this is our positive. Okay, now if we are going to look for the negative, so we are going to try. So 570 degrees minus 360 degrees times 2. Okay? So let's see. So 360 degrees. Okay? So times 2. So 570 degrees minus 360 degrees times 2 will produce negative 150 degrees. So this is our negative coterminal angle to 570. So that's it. So we can just add 360 and then subtract 360 to get the positive and negative coterminal angles.